Good morning to everyone. This is P. Satish Kumar, working as Assistant Professor in Department of CSC, Chalapati Institute of Engineering and Technology, LAM, Guntur. Today, I want to discuss the concept of process in the operating system. Let us start the concept. So, what is meant by a process? Before going to see what is meant by a process, let me tell you the what are the different names of the program we called in different operating systems. An operating system execute a variety of programs. That is, in batch operating systems, we call that programs as jobs. In time shared systems, we call that programs as user programs or tasks. So many textbooks uses jobs and process almost interchangeably in their writings. So let coming to the exact definition of the process, a process is simply nothing but a program in execution. So let me tell you the real-time example for the program and the process is what are the difference between program and process is. Suppose if I want to write a C program, I will open the text editor and write the source code and save that program with .c extension. That thing is called a program. That means the saved program is stored in the secondary storage devices. If I want to execute that program, so I have to bring that program from secondary memory to the main memory. At that time, that program is execution, so that is called a process. So is it clear what is the difference between a process and a program? So coming to the process, we have multiple parts in that particular process. We have text section, we have program counter, we have stack section, we have data section, and the heap section. So in the test section, in the text section, the program code is executed, is stored, and in the program counter, it is a counter which is used to store a single instruction that is to be executed by the CPU. In the tag section, in the stack section, the temporary data that is available in our program, whatever the temporary data, that means a functional parameters or return addresses and the local variables, what are we are used in our program is going to be stored in the stack section. In the data section, the global variables that are used in our program is stored in data section. Finally, the heap section means here we will dynamically allocate memory to that particular program. So what are the concepts discussed so far? That is text section, program section, stack and data section and heap section. So that is this is shown in this figure, a process that is stored in the memory. Here the memory means the main memory. So 0 to max is the addresses, and the text section, data section, heap section, stack section will store like this. Okay, next, coming to the process states. So when we are executing a program, that is called process. From starting to ending, the process may undergo different states. So process can change the different states. So we have five number of states, that is new state, running state, waiting state, ready state, terminated state. So the new state is nothing but the process is being created. The running state is nothing but instructions are being executed by that process. The waiting state, so the waiting state, a process is said to be in waiting state when it is waiting for some event to occur. Ready state, a process is said to be in ready state, it is waiting to be assigned to a processor. Here the processor means CPU. The terminated state, after completion of execution of all its tasks, the processor is going to be terminated. So this is the final state. So new is the starting state and the terminated is the final state. So these states will be represented by using the process state diagram. Here we will see the particular new state, ready state, running state, waiting state, and terminated state. So here the new state means, so a process is firstly brought from secondary memory to primary memory, that is RAM, is called in the new state. When the process is ready, when it is said to be a ready state. So when the process is waiting for CPU to assign, that is said to be in the waiting state. If the CPU is assigned to the process, then that ready state is changed to ready to running state. So here the CPU is executing the program instructions, process instructions. If any interrupt from the system or as well as user so that will goes to ready state or waiting state. If any interrupt is occurred, that will goes to running from running state to ready state. If any IO operation is required for that process, here IO means some inputs has to be entered manually from the users, then we go to waiting state. After the completion of the events, then the waiting state in the process is go to ready state. So after ready state, then the CPU is assigned to that process, then that process is go to running state. After the completion of all instructions has been executed, then they will go to the terminator state. So this is about the process states in OS. Thank you for watching.